this problem, I need to graph the function f of x equals x to the fourth minus 1 all over x squared minus 49. Now, in order to graph this rational function, I'll need to identify any asymptotes, any holes in the graph, let's see what else, any intercepts, and then draw my graph. So I'll start with vertical asymptotes. I'll factor both the numerator and denominator. I factored the numerator, x to the fourth minus 1, into x squared plus 1 times x squared minus 1, and then I can still factor x squared minus 1 into x plus 1 times x minus 1. X squared plus 1 is not factorable over the real numbers, and we're only concerned with the real numbers when we're graphing a function. So we've got the numerator factored and the denominator factors into x plus 7 times x minus 7. So when I look at my final result here, I can see that there are no factors that are going to cancel, and that means that we don't have any removable discontinuities, which would be a hole in the graph. So there's no hole in the graph. So now I'll look at vertical asymptotes. Since there's no hole, any factor in the denominator that can equal 0 will cause a vertical asymptote. So we've got x plus 7 equals 0, which gives me the vertical asymptote x equals negative 7. X minus 7 equals 0. Gives me the vertical asymptote x equals positive 7. All right, so I've got those two vertical asymptotes, and I'm going to graph those now. Okay, I've got my vertical asymptotes graphed, and now I need to see if there is a horizontal or an oblique asymptote. Since the numerator has degree 2 more than the denominator, then there's neither a horizontal asymptote or an oblique asymptote. So we're done with asymptotes, and now I want to find any intercepts. So I can find the y-intercept by plugging in 0 for x. All right, so I have my y-intercept, which is the point 0, 1 over 49, and I've graphed that on the graph here. And I really just put a dot a little bit above the x-axis because to try to graph 1 over 49 accurately is not going to be very possible, especially with the scale being 60 here. So I've got that intercept. Now I'm going to set my whole function equal to 0 in order to find my x-intercepts. And when we're working with a rational function, I really just need to set the numerator equal to 0, because if I set the whole thing equal to 0, we can start by multiplying both sides by the denominator, and the denominator will disappear from the equation. So we really just need the numerator to equal 0. That's what we're looking for. Okay, so I've found my x-intercepts by taking x to the fourth minus 1, set it equal to 0. We factored that above, so I just copied that down, and I set the linear factors each equal to 0. X squared plus 1 can't equal 0, not in the real numbers at any rate, so we get x equals plus or minus 1, and I've graphed those on my graph as well. So now what I'll do is I'll look at my graphing calculator and see what values I can get from the table. Okay, I've graphed a few points that I got from looking at the table in my calculator, and you can view the table. Once you've typed the function into y1, then you just press second and graph, and you'll see your table. And so I've graphed a few of those points, connected them, and keep in mind what the graph looks like on your calculator. And to view the graph just as it should look based on the axes that we have here, you can change in the window, you can change your x values, your range from negative 12 to 12, and then the y values go from negative 300 to positive 300. And then you have it exactly set up the way it should look on the axes on the exam, and the calculator and your graph here agree with each other. So that's how I would graph that function.